Hello everyone, this is Anjali Lanjavar. I am a student of Ramdev University, Nagpur. Let us discuss about the example of classical and quantum billiard board. At last, we'll also take a glance at the comparison between them. Let's get started. Before that, we must know some basics, that is classical and quantum system. The classical system is nothing but the physical systems which is based on the laws formulated by the scientists. Here are some examples, that is the motion of car on the road. Basically, the motion of the car, it is actually following the laws of motion, specifically the first and the second. It is also influenced by the friction and inertia. The rest are the same. On the other hand, the quantum mechanics deals with the phenomena at the microscopic scales, that is like atoms, subatomic particles, etc. The examples are given: behavior of electrons in an atom, interaction of photons in quantum optics, and so on. Basically, the main difference is that the classical mechanics deals with the macroscopic particles, whereas the quantum mechanics deal with the microscopic particles. Before going to the billiard ball, we first need to know what is adjacency matrix. So, adjacency matrix, an example is given here of classical deterministic system. It is saying that we have total of 27 marbles and there are 6 vertices. We can also call it indices. We might keep 6 marbles on index 0, 2 marbles on index 1, 1 marble on index 2, and so on. So this state can be simply denoted like this. So here the dynamics is shown that if an arrow exists from vertex I to j, then one time click all the marbles on vertex I will shift to vertex j. That is, you can shift all marbles of 0th index to 5th index. This arrow indicates the same. So we'll take out the adjacency matrix for it. For this arrow, we'll see from 0 and we'll search for 5. So here is 5. We got here 1. And if we see x from 0 to 0, there is no arrow existing from 0 to 0. And then 0 to 1, it is also the same, no arrows are existing. From 0 to 2, from 0 to 3, from 0 to 4. You can see that no arrows exist from 0 to 1, 2, 3 and 4. Only it is existing from 0 to 5. So we will write here 1 as here mij will be 1 if and only if there is an arrow from vertex j to vertex I. Similarly, if you have completed the matrix like this by 1 to 2, here is 1, we'll look 1 to 2, here exists an arrow. Yeah, this is the way we get our matrix. Then let us move to our main topic, that is classical billiard ball. Now here we are shifting and modifying our previous case, that is here we have 27 marbles. Let us modify our previous case, that is dealing with a bunch of marbles. Instead, we'll now consider a single particle or a single ball, it is billiard ball. Now here we will assume that our billiard ball's initial state is at the 0th vertex or 0th index. So its initial state can be denoted like this. This is our initial state. So these are the given probabilities. So as the probability of going of billiard ball from 0 to 1 is half and 0 to 2 is half. Similarly, the directed arrows show the probabilities of moving a billiard ball. Here we'll get the corresponding adjacency matrix. On observing this, we'll get the same as we done previously. This is the index 0. This is the index 1, index 2, and index 3. Here also goes the same. Yes. So if you observe from 0 to 1 it's half probability, and 0 to 2 is also the half probability. So from 0 to 1 we have 1 by 2, and similarly 0 to 2 also we have 1 by 2, and the rest is 0. So this is our adjacency matrix. Let us see what happens in 1 time click, 2 time click, and so on. This matrix we can also call it doubly stochastic matrix. It is nothing but the matrix that are having the real values, that is between 0 to 1. So this matrix also having the values between 0 to 1, that is 1 by 2, and also the sum of each rows and columns is 1. Here half plus half will get 1. Same here we'll get 1. Here also 1 by 2 plus 1 by 2, 1 and 1. We'll also get this column wise. The sum of the column is 1 and the sum of rows are also 1. This is called as doubly stochastic matrix. So in 1 time click, here this is our matrix. We have got this matrix. This is our matrix for classical billiard ball, and as we have mentioned, the ball is at vertex 0. At vertex 0, the initial state will be this 1 0 0 0, and on simply multiplying the matrix we will get this outcome. So this is the matrix we got after 1 time click, and in 2 time click we'll take the same adjacency matrix and multiply it with the output we get from the first 1 time click. So this output we'll get is the output of 2 time click. So here we'll see that vertex in 1 time click is at position 1 and 2, and in 2 time click we'll have position of billiard ball at 0 and 3. So here same, after 3 time click we'll get this, and after 4 time click we'll get this. Let us see now the quantum billiard ball. In quantum billiard ball, the same is happening. The ball is initially at the vertex 0. The probability of billiard ball from index 0 to 1 is 1 by root 2. It's a part of complex number. And from 0 to 2 is also 1 by root 2, and the rest is given. So we'll get the corresponding adjacency matrix like this, and this matrix is unitary. Here we have got matrix this is our adjacency matrix, and as initial state the ball is at vertex 0, so this is the initial state matrix, and simply multiplying we'll get the 1 time click result. Here the ball after 1 time click is at 1 and 2. After 2 time click, the ball is at 0, right? Yes, we have got the matrix that is at the initial state 1 0 0 0. This is the initial state, that is ball at vertex 0, and after 2 time click we are getting the same matrix, that is in quantum billiard ball the ball will return to its initial position or original position after 2 time click. So this is the biggest difference between these both. Let us look at the comparison between the both. Here in classical billiard ball, the weights are basically in the real numbers, that is 1 by 2 as we have seen, and whereas in quantum billiard ball the weights are in complex number. Also, in the classical billiard ball, as we have seen, it toggles between the states 1 and 0 and 3 and 1 and 2. In classical billiard ball, the first in the 1 time click we have got 1, 2, and 2 time click we have got 0, 3, and again we are getting 1, 2 and 0, 3. So basically in classical billiard ball the system will not return to its initial state. It will never return to its initial state, and it will toggle between these states 0, 3 and 1, 2. In quantum billiard ball, the ball will return to its initial state after 2 time click. This is the main difference. For 1 time click is at 1, 2. After 2 time click is at 0, 3. And similarly in quantum system, this is the original state of the billiard. Okay, so this is it for the explanation of the topic, example of quantum and classical billiard ball.